Okay, so I have a video here for you today that's all about how to locate the vertex of the parabola, and we're going to do it in three different ways. One is the equations already are been graphed, and so you have the parabola right in front of you, or you have equations, and we're going to talk about how you can lift it from the equation. And then the other way, which I'll flip to the whiteboard screen when I do this one, there's an algebraic approach where we can also find the vertex from knowing the line or axis of symmetry. So right here is a Desmos page that I have. Each grouping of 3 is a triplet to a parabola. So watch this. When I click the 4, their equation 5 and equation 6, they all yielded the same parabola. And that's because this is a triplet where they all are the same quadratic but in varying forms. And so as a quick review, this is standard form, this is factored form, and this is vertex form. So right away, you can tell that the vertex of this parabola you could lift right from the equation, the vertex form. So watch this. When I go to this point here and illuminate it, I get that my vertex is 8 comma -1. And you can see that that's in here. I have a video about how to do this, so feel free to look at how to find all the different ways you can find the axis of symmetry line on my YouTube channel. So this right here shows us that that's an 8. In that video, I talk about why it's not a -8 but a +8, and then a -1 you take as is, and so that is our vertex. What I also wanted to show you was if I go down here, here's a parabola that faces downward, right? So it has a negative value in the lead coefficient. So when this triplet, they go together. So I'll just click them all so you can have that proof that they all are the same parabola. Here in the standard form, it's much more clear. The lead coefficient is a -2. And that tells us that not only is this parabola more narrow because it's increasing at a doubling rate, but also it's negative, it faces downward. Our original triplet up here was a positive coefficient, and there's nothing written there. We assume it was 1. So this parabola that we see in green is following more the standard shape of a parabola in this ratio of 1 moving along X and Y pattern. So just take note here that in a parabola that faces upward, the vertex is the very lowest point, right? And in a parabola that faces downward, the vertex is the absolute highest point. Okay, so that's a slight difference. So visually, if you've got your graph plotted in Desmos or by hand, you're looking for the peak of a downward parabola or the lowest point, the valley or trough of the upward facing parabola. And that's how you can visually find your vertex. And again, the other way is if it's straight from vertex equation, vertex form, you can lift it right from the equation. You would have to transform factored to standard to get to vertex if you wanted to go that route, or there is a way by completing the square, you can transform standard form into vertex and then lift out. And again, there are videos on how to transform from one equation form to another. So you can, and then once you transform into vertex form, then you can lift right out. So this actually takes care of the 2 different ways that you can use the visual of the graph and the equation to help you find the vertex. But also here, let's just make that connection clear again. The vertex is going to occur at the point of, at the line of symmetry, because this is the mirrored image point of the parabola. So I'm just going to zoom in so you can see that we have an intersection here at the x equals 8 line. Remember, x equals 8 is always a vertical line, and then the line of symmetry or axis of symmetry is always going to cross exactly at the vertex on the x component. So they share it. So if you can find and that's what our next portion will go to, is the algebraic approach. If you know your axis of symmetry, you can use this value to find the corresponding y value in order to find the point that is your vertex. Okay, so let's just close out of here and come here. So we're going to say that we already know, we're going to say we have a problem here. We already know that x is, the line of symmetry is x equals 6. We're going to say that. So we know that this is our line of symmetry, and line or axis of symmetry. If you hear different vocabulary, they're meaning the same thing. And we have an equation here. Let's say we have factored form and standard form. I'm not going to show this with a vertex form because, again, you can just lift the answers right out of vertex form. So let's say we have a factored form of a parabola that is, maybe I'll write it, that is x squared. Sorry, this is the standard form, x squared minus 12x plus 11. And then the factored form of the same quadratic is x minus 1 and x minus 11, okay? And these are both y equals, or f of x. I'm going to leave them as y because we're looking for the vertex. We are looking for the y component. There's no harm in having it be solving for f of x, but I think just for simplicity's sake, I'm going to have these be y equals equations. And so if we know already that this was given, or we were able to find it visually, or we calculated it according to other videos I've shared on how to find the axis of symmetry, then you can just do a substitution step where you're going to take this value of 6 and plug in to the x's of each equation. Now, you don't need to do it actually to both in real life. You just need to pick one of them. So if you only had standard form available to you, then you substitute the x value in for the x. And so I'll just show that real quickly here. Minus 12. Parentheses are always a key when substituting. It will really help avoid pitfalls and errors. Okay, so all right, so when you go to consolidate this, you're going to get y equals 36 minus 72 plus 11, and all that becomes y equals a negative 25. So let's think about what this means. This means that y will equal negative 25 only when x is equal to 6. And so right away, what that means is we have found our vertex. The vertex occurs at 6 comma negative 25. Okay, so right away, the vertex has been revealed. So if you're doing this work, but instead with the factored form, again, it's going to be a pretty similar approach. You're going to substitute in for the x, you're going to, oh, I already have it there. You're going to substitute in, and then when you go to consolidate, you are going to do 6 minus 1 is 5, but 6 minus 11 is negative 5. But again, you'll see that we get y equals negative 25. There we go. So again, this is saying y equals negative 25 only when x equals 6. So either way, you're going to reveal your vertex. So I hope this was helpful in helping you see that you have so many different pathways depending on how the problem has started you off. So if you are starting with the graphed parabola, you can lift it out visually if you know which part anatomy-wise to look at the parabola where the vertex is. If you have the vertex form, you can lift it out there. If you know the axis of symmetry because you calculated it, or it was provided, or you found it in some other means, then you can use that substituted in order to find the y component, because remember, the vertex and the line of symmetry always intersect together. They share the x line, that is the axis of symmetry. That's the same value, that is the x component of your vertex, right? So here we have the vertex x component is 6, and it matches the line of symmetry that we were starting with. So I hope that was helpful, and continue all of the great work you are doing.